you to do your homework, written assignment, after very fruitful discussion among your peers. All right, I feel very happy that Dr. Jerry Rao, my husband, who has accepted my invitation to come to share his expertise with you on, as a biologist, on information on stem cells and cloning. Let's welcome Dr. Rao.
Thank you, Professor Rao, for that wonderful introduction. Okay, yes, I'm a biologist. I taught biology at high school for many years and college for a couple of years. And this obviously is a topic that comes up frequently in biology class because it mostly is biology. But what are stem cells? There are a lot of different kinds of stem cells, and there are a lot of different kinds of cloning. So when somebody says stem cell research, the first question to ask is, what kind of stem cells? What are you going to use them for? When they say cloning, what kind of cloning? What are you going to do with it? So let me start by just giving you an overview of types of stem cells and why they occur, what it really means. At the beginning, the embryo is what's called totipotent. Toti comes from the same word as total. Okay, it means everything. So the totipotent cell can become everything in the body. Obviously, the embryo, that first cell in the embryo, becomes everything. So at the first cell, the second cell, the third cell, for a few divisions, it can become a complete mature organism. But after about 5 divisions, it already starts to differentiate. It already starts to divide into different parts, even at that very, very early stage. And then it becomes what's called a pluripotent cell. Pluri from the same root as plural. Plural meaning many of the same thing. So at this point, it can develop into many different cell types, but not everything. And then as it goes a little bit farther, different types of stem cells are formed. Blood stem cells, for instance, can become red blood cells, white blood cells. There are actually lots and lots of different kinds of white blood cells. Other stem cells can become other things, but they're limited. Stem cells in the skin can become maybe 10 different types of cells that are all found in your skin. But they can't become muscle or heart or bone at that point. So at that point, they've begun to differentiate. They've begun to become different. And that happens throughout the process of the organism growing. And then somehow, one of those cells that became part of the uterus in the woman or the testes in the man gains the ability to form a new totipotent cell. Okay? It's already differentiated into forming gametes, forming eggs and sperm, but then those eggs and sperm, when they get back together, somehow become totipotent again. And that's something that's really not understood yet, how that works. How you take a cell that's already become specialized and make it unspecialized. That's what we really want to do. Because if we did that, then all these other ethical issues are not a problem. Okay, so again, just in terms of what goes on in the zygote, you have this totipotent. As an embryo, it becomes pluripotent, or spelled two different ways, but it becomes pluripotent, then multipotent, oligopotent. Oligo just means a few. So you have mini oligo. That's actually from the same root. It's from a few things linked together in a chain, in mini oligo. And then tri or bi, that's 2 or 3. And then nullipotent, null means none. It can only be that one thing. And this happens to every cell in your body. It goes from at the beginning, starting as totipotent, and it gradually becomes more and more special until it can't be anything else. So again, once this becomes an egg or sperm, how does it go back to here? We don't know yet. If we did, that it would be easy to avoid all these problems. So again, as the embryo develops from a single cell to 3 days to about 5 to 7 days, we're still dealing with totipotent. They can become anything. 1 week. Okay? By the time you're at 4 weeks and the embryo begins to look sort of like an animal, but not really a human yet, they become pluripotent. They can be many things still at that stage. As you get to about 6 weeks or a little bit beyond that, they begin to differentiate. At that point where the thing begins to look human, those cells begin to act like individual different functions. And then here's another type of stem cell, which we'll talk about in a minute, called the cord blood stem cells or placental stem cells. Okay? So far, all of these cells we've talked about are embryo. Okay? They're embryonic. They're from the embryo itself. But you know, when the embryo attaches to the mother, there's this cord. Okay? The cord that becomes your belly button. And it attaches to the mother's placenta, this part that is inside the womb that supplies nutrients. And both of those have certain cells that are also pluripotent. Okay? Now, if you take these cells, when they're totipotent, if you take those and use them for research, that organism is dead. Probably. Because there's no good way to take one cell out of that. But if you take these cells, the ones from the umbilical cord or from the mother's placenta, you know, that's fine. I mean, after the baby comes out, you cut the cord, you throw the cord and the placenta away. So a lot of people now are looking at this as a good source of pluripotent or multipotent cells. They can't become everything, but they can become a lot of things. And then, same thing, in the adult, there are certain cells in all parts of your body that still are not completely differentiated. They're not completely one type of cell. And so, again, we're finding ways now that you can take skin and you can take those cells and you can make a whole new layer of skin. Okay, so there are different things that can be done. Now, you were just talking about when does life begin. And these are some things that happen during the course of pregnancy as far as time. Day 1, fertilization. The egg and sperm meet. Day 18, 3 weeks, the heart starts beating. By week 6, the brain waves, you can measure the brain waves in the organism. By about week 8, all the body systems are there. And by about 11 weeks, they're all functioning. Now that's during the first trimester. Did you introduce that term? Okay. First trimester. Normally pregnancy takes 39 weeks. So one trimester is 1/3 of that is 13 weeks. Abortion, most places, is legal at least through the first trimester. By that time, all the body systems are working. By week 16, 4 months, the mother can begin to feel the baby moving. It's already been moving for a month, but she can begin to feel it at that point. Second trimester, yeah. And then by week 24, about half of the babies that are born, they may be only this big. But with our modern medicine, they can still live by week 24. That's still in the second trimester. Okay? So,
so in other words, 20 weeks is right here.
Right where? 24
Second.
weeks. Yeah.
20 weeks, because that's the decision.
Oh, that's the decision?
Justice Kirkland
Right.
made.
Yes. And so 20 weeks is right in the middle of that. The mother can already feel movement. And at that point, at week 20, about a quarter, if the baby is artificially induced, if the baby comes out whole in one piece, about a quarter of them could live with our modern medical technology. Okay, now, what about cloning? You can come back if you have questions about stem cells. But cloning has actually been done for thousands of years with plants. Every time that you take a cutting from a plant, this is a piece of a stem, just cut it off, and you create roots and it'll grow a new shoot, that's a clone. That's still the exact same genetic material as the parent plant. And for about 20 years, we can do that with sugarcane. They just cut a piece of sugarcane, throw it in the ground, grows again. Pineapples, you just take a shoot off, cut it off, stick it back in the ground, it grows again. All the pineapples of one variety are exactly the same plant, you could say, because they're all clones. They're just pieces broken off and grow it over and over and over again. So with plants, this is very easy. Now we can even do single cells. You can take a plant, sort of break it up into single cells, and then let it grow. And as it grows, it forms this little white mass of cells. And then you treat it with chemicals, and it will either grow a shoot or roots. And then eventually you can grow it back into a complete plant. We've been doing this for 20, 30 years. What's new is cloning animals. Dolly, the sheep, was the first one that was cloned. And what they did was they took, here's Dolly's mother, if you will, the one that became the new Dolly. And what they did is they took cells from her mammary glands. It's the equivalent of the sheep's breast. There are stem cells in there. And so they took some of those cells that are undifferentiated and they grew them, and then they took the nucleus out of that. At the same time, they took an egg cell from another sheep, and they took the nucleus out of that. Then they took this egg cell with no nucleus, this nucleus, and put them together. So here's the nucleus from Dolly's mother, and this cell from an embryo. It would have become an embryo if this nucleus had not been taken out. And then they put it in another sheep, and then Dolly was produced. So this genetically, Dolly was exactly the same as this mammary cell donor, but produced by this process of fusing things. Now actually there were about 300 cells, and they got one sheep out of it. It was not very efficient. But it's gotten better. It's now at a point, about every 10 times they try this, they can get one animal with some animals. But it's still not perfect. Now, cloning has a lot of different applications. One is called therapeutic cloning. Therapeutic cloning is when you make new body parts. Okay? If your skin if you're very badly burned and you need a new layer of skin, they can take those stem cells from an adult or from the umbilical cord and create new skin. Skin is relatively easy to grow because it's just one layer. But they're working on things to try to grow new hearts, new kidneys, new livers. And the problem is, with skin, it's flat, it's two-dimensional. With a heart, it's three-dimensional. So it's harder. But by creating sort of ways to train these cells how to grow, they're getting close. And probably within your lifetime, therapeutic cloning will be possible. And so a lot of people now, when they're born, the people who are aware of this are saving some of the cells from the umbilical cord or placenta, so that when that child grows up, they'll be able to use this procedure with their own cells. And there won't be any problem with rejection, because it's their own cells. It's exactly the same. The more controversial one is called reproductive cloning. Reproductive cloning would be taking a cell from me and making a new individual, like they did with Dolly. Okay, that has not been done, and no ethics committee anywhere in the world would approve it at this point. Because that new thing, is that me? Or is that something new? Is that a new individual? It's exactly identical to me, but many, many years younger. That's my cells. Could I say, okay, you grow up to 20 years old, my heart fails, I'm taking your heart. I gave you life anyway, you're just part of me. So that's why this is not being allowed at this point, because the ethics, when you get into that, would be really horrible. Okay, if you have questions, I'll be glad to try to answer them. I think that's it. Yeah. Any questions?
It's a good opportunity. If you have anything that you want to ask concerning this presentation, anything unclear?
Anything about the biology?
Yes. Or perhaps some questions you raised in your group discussion, you're not sure about some definition?
Yes.
The law said that after 20 weeks, so after 20 weeks, the woman couldn't have an abortion, but we saw that on the week 24. I mean that if a woman have abortion at the week of 20,
At 20 weeks.
Yeah, like in the 20 weeks. So the baby is the
Premature baby, right?
premature baby. So if the woman got a abortion, so the